Welcome back. Thank you for clicking on today's video. Today we're going to be finishing up our Phred method for two independent t-tests. So remember that the R in Phred is reviewing conditions, and these conditions, because it's quantitative data, are very similar to what you've had in the past. You need to have data that's symmetric and without outliers. However, that's always in the context of sample size. And the reason I say that is because if you have a really big sample size, it can withstand some asymmetry and outliers, but if your sample size is really small, it wouldn't be able to withstand that at all. The only thing that I add is you have to make sure that your data is independent, and that to me is important because when you're doing these problems, if the data isn't independent, then the rest of it doesn't make sense. So we have the same as before in the context of sample size, and then we're adding that the data has to be independent. So then the next two we have is executing calculations and drawing conclusions. And here we're calculating a t-test statistic. And really with this data, there are other formulas with the idea of equal variance is assumed or equal variance is not assumed. I'm not going to get into that because that's really theoretical. Just know that for this class and this purpose, we're using this formula. So remember that because it's two populations, they have their own measurements for the sample mean, sample standard deviation, and sample size. And then the second population has its own sample mean, sample standard deviation, and sample size. So this is the formula for finding your t-test statistic. Remember that the reason you do that is to find your p-value. And so because it's a t, we're going to be finding that the same as we did for paired data. And remember that that t gives us a location on the curve. So when we find our p-value, we need the t. So let's just say, for instance, that it's here. And, excuse me, we also need our alternative because it tells us how to highlight. And remember that this alternative, this direction, is telling us what we're interested in. And remember that there are three other options, and we looked at that in the last video. And then you also need degrees of freedom. Now, degrees of freedom is a complicated measurement for this particular data, and there's a very involved formula. So if you're using the computer package, you would use the degrees of freedom that it gives you. If you're doing it by hand, we're going to use what's called the conservative degrees of freedom, where you take the smaller n and subtract 1. So in our degree of freedom calculation, if you're doing it by hand, you would take the smaller n minus 1. And then you would use the calculator the same way that you have in the past. You go second bars and then the TCDF. And then remember that your lower bound is where the highlighting starts and your upper bound is where the highlighting ends. So these older calculators, that's the order. It's lower bound, upper bound, and then degrees of freedom. In the newer ones, it prompts you for that. But essentially, this drawing helps you to know what to do in the calculator. So once you find that p-value, you would do the same decisions based on that p-value as you've done in the past. So small p-value means that you reject the null, and a p-value that's not small means that you would fail to reject the null. So that's nice because that's review, and that's always the case with hypothesis tests. So this part always stays the same, as does really the drawing conclusions. So you're always going to be talking about the amount of evidence you have for your alternative. So if you reject, remember that that goes with sufficient evidence for the alternative. And if you fail to reject, that goes with insufficient evidence for the alternative. Now, the nice thing about these is you'll have two parameter definitions. So when you write out your alternative, you'll write the parameter definition you have for mu1, and then you would say whatever symbol is here. So if it's greater, you'd say greater. If it's less, you'd say less. If it's not equals, you could say not equals or differs, and then you would write the second parameter definition. So I will show you how to do that in future videos where I do examples, but for right now, those are the generic parts of the Phred that we hadn't covered yet. So reviewing conditions, executing calculations, and drawing conclusions. In future videos, we'll do real examples. See you there.